Now, you can find what we call the residuals. The residuals are the difference between your predicted equation and the real data. So this would be a residual. If it's above the line, it's positive. If it's below the line, it would be a negative residual. And then the better fit would be all the points as close to the line as possible. Your calculator actually does the residuals. So here's an example of we have the residuals. Now, notice we drew a box around them to square them because the further away you are, the worse fit it could be. So what happens is your calculator goes through this data and it says, well, if I drag this, notice my sum of all these squares, it's getting smaller, isn't it? Until I get to about 25. Oh, there I start thinking it bigger then. And then I could change my y-intercept, and we can get the actual line here. Now, if I show my actual line, that's what it would be. That would be the smallest we have. Now, if you take your data and, let me get this here. If I drag it so everything's below, well, that's a poor fit. I want some above and some below. And that's what the calculator goes through, is it does this and it finds the ones that are the smallest total. You might have some above and some below, but we want the smallest total. We can do that by looking at some data here. And so what happens here, the table shows the average price of a 10-person Thanksgiving dinner from 2004 to 2014. I want to know whether the best fit line models the data well by graphing the residuals. So let's show you how you graph the residuals. First, we just plot our data like we normally do. And I put the data in Google Classroom or on your textbook. I think it's called example 3. And I'm going to start here like I normally do. I'm going to find my least squares regression line. So y tilde is m y1, then tilde, and then it's m x1 plus b. And I probably should adjust my graph so I can see everything. So I'm going to go from negative 10 for my x. Oh, that was my y. I'm going to go negative 10 to, let me see, let's go to 20. And then that's 30 divided by 10, so I'm going to go step of 5. And then we are doing the years since 2004. Okay, then I'll look at my y's. My y's go from 35 to 49. So I think I'm just going to start at 0. And I will go up to 75. And I'll take a step of 10. And this will be the price. And so I can see my data. There is my data. Now, I've got some points above, some points below. I can look at that. Now, if you look here, it says, do you see under the Y1 column or box, it says residuals. I'm going to plot my residuals. So there's my residuals, negative 0.2, negative 0.7, negative 1.1. Now, it's kind of confusing having my residuals and in my least squares regression line. So I'm going to turn off my line. And then you see the little magnifying glass next to residuals. If you click on that, there's my residuals. Notice I've got some above, some below. What you don't want to see is you don't want to see a pattern. And I don't see a pattern here. It's kind of like a scatter plot. And notice your R value is 0.95. So yeah, that's a pretty good fit, isn't it? So your correlation and residuals kind of give us the same information, except the residuals will show you if there's a pattern. You might have a good R value, but if they're all above or all below, or you start to see a pattern that shows up, then it's not a good fit. So this would be, yes, it's a good fit. Based on our residuals.